Hello, my name is Iftikhar Mahmood. I'm presenting the paper titled Predicting Crop Prices Using Machine Learning Algorithms for Sustainable Agriculture in the conference IEEE Region 10 Symposium, Tensymp 2024. The other authors beside me are Pujarani Das, Mohammad Habibur Rahman, Ahmed Rafi Hassan, Kamrul Islam Shaheen, and Dewan Namdi Farisar. This is our presentation outline. Moving on to the motivation. Our study is about price forecasting, and it helps in economic planning. Policymakers rely on price forecasting to ensure market balance. It also helps to reduce supply chain disruption. It also promotes sustainability. Most importantly, it helps the farmers in crop selection and harvest timing. Moving on to the objective. The objective of this study is to evaluate different regression models to determine the most effective approach, to use performance metrics like R-squared value and mean squared error to measure model performance, and to analyze the importance of price forecasting in agriculture. Overall, our study is to identify the most effective regression model for accurate crop price forecasting, aiding in sustainable agriculture, and providing insights for better decision making by various stakeholders. Moving on to the related work. So we have reviewed a study made by other authors before us. First, we have Gutake. In their study, they have found decision tree regression to be the best model with 92% accuracy for crop price forecasting. Pandit Samuel, they found XGBoost to be the most accurate for crop price prediction among several models. Next, we have Petchalak. They found ridge regression that outperformed Lasso in predicting high rice export prices with lower error metrics. Next, we have Vincent Joshua. In their study, they found GRNN outperformed multilinear regression in crop yield prediction across 28 districts. Next, we have Iodele. In their study, they found ARIMA as the best model for short-term stock price prediction on NYSE and NSE. Next, we have Jiao. They found attention-based LSTM model with wavelength denoising achieving high accuracy in stock price prediction. Moving on to the overview of methodology. We have the datasets, and in our dataset we have multiple crops. All those crops goes through an exploratory data analysis and descriptive statistics where we find mean, median, standard deviation, kurtosis, and skewness. Then we pass all those crops through different regression models, and then we evaluate all those values using performance metrics like R-squared and MSE. Then we dictate the final result. Moving on to the dataset description. Our datasets were obtained from Agriculture Service Portal of Ministry of Agriculture in Bangladesh. Our dataset consisted 13 columns, all of them. In 13 columns, we considered 11 of them as features, such as year, month, week, division, district, upajala, market name, commodity group, commodity name, retail unit, and wholesale unit. Two of them was considered as target variables, such as retail average price and wholesale average price. In total, we have 4,872 data instances for all crops combined. In all of our datasets, we have 6 crops such as rice, wheat, onion, tomato, potato, and oilseed. We did an extensive exploratory data analysis on each crop. We inspected each dataset for missing values and duplicates, and we have addressed those using interquartile range data planning method. We have also calculated mean, median, standard deviation, kurtosis, skewness for all the crops to gain insights into the distribution. For example, rice. From rice, we see that in the retail average price, rice have the mean of 45.95, median of 51, standard deviation of 20.85, skewness of minus 1.40, kurtosis of 0.81, which is a narrower range than tomato. Just like this, we can get insights into the distribution. Moving on to the result and discussion. So we have implemented 7 regression models: linear regression, ridge regression, lasso regression, decision tree regression, random forest regression, support vector regression, and AWS regression. We have used k-fold cross-validation to divide the datasets into training and testing sets for each fold. and we assessed the effectiveness of each model using R-squared value and mean squared error. Now here is the result of all the crops. So as you can see, rice, onion, and oilseed work really well with decision tree regression model, as shown that they have the lowest MSE values among all the other regression models and the highest R-squared values among the regression models. Tomato and potato work really well with adaptive regression, and wheat work really well with linear regression. Let's take oilseed for an example. So from the MSE, we can see the oilseed value oilseed has the value of 0.846 for decision tree regression model and 1.643 for AWS regression model. The difference between those two values isn't that big. The next value after AWS is a random forest regression model with 5.134. The difference between AWS and random forest is really high. If you now check the R-squared values of oilseed, you will see that decision tree have 1 and also AWS have 1, which means in this case decision tree and AWS both actually works really well, but among those decision tree works the best. We also observed residuals plot for wholesale and retail prices. So for rice, as you can see that for retail price in the rice there is a slight curvature, which implies a potential non-linearity. And for wholesale, it randomly scattered around 0, which is a satisfactory fit for regression models. For wheat, we can see that it has a funnel-shaped pattern, uh, which indicates a heteroscedasticity. It is also same for the wholesale of the wheat. It also shows a slight funnel shape, which also indicate a heteroscedasticity. For oilseed, both wholesale and retail scatters randomly around 0, which indicates a good fit. Now for the conclusion. So from our study, we have decided the results indicated that from our study, decision tree regression, AWS regression, and random forest regression outperforms all the other regression models in terms of price forecasting. Now, what is the future scope? So the future scope that diverse data sources could be integrated like multimodal data. Model explainability techniques like shapely additive explanation and advanced machine learning techniques could also be incorporated. The analysis can also be extended with external factors such as weather, geopolitical events, and market dynamics. These are the references that we have used in our presentation. And thank you. That is all. That concludes our presentation. If you have any question, I'll be happy to answer.